Now let's try to add in few more controls into the UI. So what we are going to do, instead of touching the existing application and XAML, what I'm going to do is I'm going to add one more XAML file into the project. So I'm going to simply right click on project and add one new item. Either you can click on new item, or we have option here, we can add a window which is WPF window. So either way is fine. I'm going to click on new item, and then what we can do is from the section called WPF you can pick up your window WPF. So I'm going to give a name to this XAML page as in window2.xaml, and let's click on add. Rather, we already have one main window, so let's keep it as window1.xaml. After you add it, you will find out it has got same sort of window, same sort of grid here. And then as we discussed earlier, I'm just going to focus on XAML only, and then we are not going to drag and drop anything. So we have a window, and if you look at the project structure, we have app XAML, we have main window XAML, and we have now window1.xaml. So when we run the project, by default it will show main window.xaml. Reason behind that, there is an entry made over here as a startup URI in app.xaml. So in order to show window1.xaml, what I want to do is I want to change this to window1.xaml. Again, is there any way that we can navigate from main window to window 1? Yes, there are multiple number of ways available. We are yet to see navigation. That's the reason we are holding it as of now. So window1.xaml will be the startup file now. So what I'm going to do, I'm going to close all the files that we have here. So maybe we can right click and we can say close all documents here, and then we will focus on window1.xaml only. So just to show that when we run, it will show me blank file, and this is what we want to decorate with controls now. So by default we have a grid layout. By default there are like single cell is what we have here, and we have been adding all controls into the single cell. Rather, we have added one control button, and then there was a control inside a button so far. So we haven't added actually multiple number of controls into the grid itself. So there was only one control we dealt with. So here is what we plan to do now. I would like to have here maybe 2-3 text boxes, and I would like to have a button on the screen. So what if I keep on adding maybe 2-3 text boxes like this? So one text box I will add. Let's name this text box as, this text box is for showcasing name of the person. Maybe I'll say it as txt name, height 80, width 200. Now when we say text box has height equal to 80 and width equal to 200, what does exactly these values mean? Though I said these values are not pixels, these are something called as DPU or something which is called as DIP. So let's try understanding what exactly these values are. So device independent unit or pixel. So with the introduction of WPF, what Microsoft did is they began using something called as device independent units. This is also well known as DIP. So this measurement is based on top of inches. So it's not with respect to hardware specific pixels. So in Windows forms we had hardware specific pixels. So we always used to put up values with respect to 20 pixel, 30 pixel or pixels in general. Pixel simply represents one single point on your screen. So how exactly DIU is calculated then, or DIP is calculated? So it is normally 1/96th part of, or 1/96th of the inch. So ultimately it is smaller than the point. Normal point is always defined as 1/72 of inch. So in general you will find out, which means 1 point out of, if I divide inch into 72, it's like 1 part of it. So for a standard 96 pixel per inch monitor, so you will find out 96 DIU is equal to 96 pixels. And then for monitors with 120 pixels, it is still same. So it's like 96 DIU will remain common with respect to the, you can say the pixel sizes. So if at all one monitor per inch showcases 120 pixel, in short, if one monitor per inch showcases or puts up 120 pixel, then we will see that 96 DIU is equal to 120 pixels. If one monitor is going to go and show per inch 96 pixels, in that case, since it is per inch 1 by 96, so I will say it is something called as 96 DIU is equal to 96 pixels. So you will find out the unit is that way independent of what we call it as a device. So it's not specific to the hardware right now. So that's the reason WPF, you will find out it works better on a device like maybe a laptop device. It also works better on a desktop device. It works better with a small screen or a larger screen. So your controls are actually so-called rendered very well with respect to your hardware sizes, or I would say hardware and the resolution. So it's based on top of both the factors. So let me continue adding a couple of more text boxes. I'll add one more text box and I'll add one more text box. Let's name this text box. Text box names has to be unique. Let's add this as age, and let's add another 2 are sufficient as of now. And then let's have one button here. So one button with name as in BTN show, then height 80, width 200, and let's close this text box. So we have added 3 different text boxes inside a grid. Grid is right now single cell kind of a control. So how exactly it will look like? All controls are of same sizes if you see. Now you'll find out only one control is visible. So it has actually put up all controls one on top of other. However, I really wanted these controls to be one after another. So grid, unless and until we define so-called rows and columns, you will see that it's not going to go and put up these controls in a proper manner. There is one more way that putting a margin, but which is kind of what we call it as, it's not a kind of a suggested way of putting the control. So what I'm going to do is, I'm going to change this grid layout to something called a stack panel for a while. That way we will be able to see stack panel as well. So as I said, by default stack panel orientation is going to make sure that first control is always at the top, then the second control will be after that, then third, and then fourth, and so on. So if you see, and if I run this, you will find out button will be the last control which is shown over here. So this is name text box, this is age text box, and this is the button that we have. I need to add something on top of button, so I'm going to put up here something like content, and I'll say click me. And on click of this button, we will simply write down one event handler. So if I go back, there is some event handler that we have here. So what I want to do is, I would like to get the text box's data, and I would like to present the text box's data. So we saw this earlier as well. We tried to read the text box's value with the help of .text property. Exactly in the same manner, we can collect this value and we can very well showcase this value into the alerts. So as of now, I haven't done that. It's just a UI that I have put up on the screen right now. This is something which is feature of like running through Visual Studio. It can actually help us understand something called as visual tree. In a while, we will be using these tools on the screen. So as of now, we have 2 text boxes and 1 button. So here is what I'm going to do now. I really wanted not to only collect these values from text boxes, I really wanted to set the values as well programmatically. It's not a big deal, that's what it seems to be, because just like I can set up the value for text box, I can always get the value from text box. So it's just going to be textbox.text equal to something, or we can just have a variable declared and we can collect the value from text box's text. So setting and getting the value manually is always easy, whether it is Windows Forms or whether it is WPF. But then what we are trying to be concerned about is something like one concept called as data binding. So now we are going to move to data binding, and we will understand this topic in a very depth.